My name is Reuben Covey, and I'll be discussing my results from Lab 2 surrounding the topic of gravitational forces. In this lab, we are studying the effect of gravity between two forces and the idea of uniform circular motion with both perpendicular and parallel components. With our first computational model, we are calculating the mass of a black hole based on the trajectory of a star orbiting that black hole. In the second model, we then use this calculation to determine the initial velocity needed of a spaceship to be able to exit a planet's orbit, get close to the black hole to observe it, and then continue its escape from the gravitational forces without crashing. By far the most important physics principle was that of the formula for the gravitational force between two objects, which is equal to negative g times big M times little m over r squared times r hat. We also use both the velocity update and position update formulas within our calculations, which are related to Newton's second law. The final important formula to use was the relation that equates F net to dp over dt, which is the change in momentum over the change in time. The first step of the model was to set up the initial conditions of the system and surroundings, such as the gravitational constant, relevant masses, as well as the delta t interval. It is important to note that the initial mass of the black hole in part 2 is the derived mass that was calculated from part 1. The first calculation we did in our computational model for calculating the mass of the black hole was to multiply mass by velocity in order to find momentum. We then found the change in momentum over the change in time, as well as the p hat vector, which could be multiplied together in order to find dp dt parallel as well as dp dt perpendicular. We could then find F net, which was equal to dp dt, and then use this in our formula for gravity to find the missing variable of the mass of the black hole. Within every iteration, the model would print the calculated masses, which can be seen in the table to the right. After calculating the average of all of these results, we found the mass of the black hole to be 8.88 times 10 to the 33rd kilograms. In the next computational model, we first calculated the net force acting on both a planet and a ship by their surroundings. This was done by finding the r hat vector between the two objects and plugging the distance and mass into the formula for gravitational forces. Since each object was being affected by two other objects, we summed together the two forces in order to find net force. We could then use Newton's second law and the velocity and position update formulas to create a trajectory for the motion of both the ship and the planet around the black hole. This allowed the ship's trajectory to be changed solely off of its initial velocity, which would be modified in the code. We then wanted to find which conditions would satisfy having the ship fly very close by the black hole in order to observe it before then flying away from the black hole. After a series of trial and error simulations, I found one optimal initial velocity to be setting the ship's velocity in the x direction to be negative 9 times 10 to the 7th meters per second, and the ship's velocity in the y direction to be 5 times 10 to the 6th meters per second. This caused the ship to shoot out away from the planet in the negative x direction, allowing it to fly by and observe the black hole before allowing the black hole's gravitational pull to slingshot the ship away at a slight angle. When studying the results from each iteration, we can see that calculated mass varies within a range of about 0.5 times 10 to the 33rd power. One possible source of error for this is that we are letting an entire day pass between intervals and calculations. Another possible source of error is that we assume that the black hole was the only force acting on the system, but in reality, there would likely be many forces acting on the system. For part 1 of the extra questions, the rate of change of momentum is describing the change in the system's velocity related to time, while net force is the strength of the force being applied to an object which causes a change in its motion and specifically an acceleration of that object. For part 2, with an initial x velocity of 9 times 10 to the 4th and an initial y velocity of 8 times 10 to the 6th, we were able to find that the ship entered its own orbit around the black hole that was separate of the planet without crashing, as shown in the image to the right. Thank you very much, and I hope you enjoyed.